The question says that a circular coil of 30 turns and radius 8 cm carrying a current of 6 ampere is suspended vertically in uniform horizontal magnetic field of magnitude 1 Tesla. The field lines make an angle of 60 degree with the normal of the coil. Calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. Would your answer change if the circular coil in A were replaced by planar coil of some irregular shape that encloses the same area? All other particulars are also unaltered. In this question, there is a coil that is suspended vertically in the uniform magnetic field, and its area vector is pointing 60 degree with the magnetic field, and we have to find out how much torque would be required to prevent it from turning. So basically we have to find out what is the torque that is being applied on the coil. So we know that torque on the current carrying coil is given by the cross product of the magnetic moment and the magnetic field, and this simplifies to NIAB sin theta, where N is the number of turns, I is the current, A is the area of the coil that the coil encloses, and B is the magnetic field, and sin theta is the angle between the area vector and the magnetic field. Now we have been given this data, we need to find the area that we can find out since it is a circular coil. So pi r square, we will use this formula to find out the area, and substituting the values we will get a value of 3.14 Newton meter. Now the second question also asks that whether if we replace it with some irregular shape of the same area, that of the circle, then will the torque change? So in this formula of torque, we see that it doesn't matter what is the shape of the coil, it only matters the magnitude of area. Since it is not changing, so the torque will also not change. So the answer would be no, the torque won't change on changing the shape of the coil. Thank you.